All right, so today let's talk about gravity and free fall. So I'm going to zoom in on our objective. So the objective today is to be able to describe and calculate various components of free fall motion. Again, our topic is gravity and free fall. And the essential question for today that you all should write down and try to answer in the summary of your notes from this video is, what is gravity? And the second essential question is, how does gravity affect objects in free fall? So key term here, let's talk about what gravity is first. So what is gravity? Zoom out a little bit more. Okay. So gravity is defined as the universal force of attraction between all objects. So let's talk about what that means for us when we are talking about free fall motion. First, we need to define what a force is. A force is a very simple definition. It is simply a push or a pull. So gravity is a pulling force. If we zoom in a little bit more here. So when you all are on Earth, gravity is going to, say this is you right here on Earth. Gravity is going to pull you toward the center of the Earth. It's a pulling force. It wants to pull you closer and closer to the center, its center, okay? So key thing to remember here, gravity, while it is a force, it gives us a certain acceleration, okay? So when we are falling, we are going to fall and accelerate in our fall at a rate of negative 9.8 meters per second squared. So key thing to remember here is this negative sign. So this negative sign, again, if we are looking at our X and Y axis planes, okay, here's our Y, here's our X. If we are falling in this direction, because again, because of gravity, we're not going to fall upward. We're only falling downward. We are falling in the negative direction, in the negative Y direction. So that is why we have that negative sign there for gravity. Okay, so the acceleration due to gravity is what we call a constant. A constant means that it will never, ever change. So the acceleration of an object due to the force of gravity on Earth is always going to fall with an acceleration of negative 9.8 meters per second squared. Because this is a constant, we actually give it its own variable here. So its variable that we use for the acceleration due to gravity on Earth is the lowercase g. So remember, our normal variable for gravity, or excuse me, our normal variable for acceleration is that lowercase a. Right? A equals acceleration. G is our variable for the acceleration due to the force of gravity. So G is still talking about acceleration, but since it is so special, since gravity's acceleration is so special, we give it its own variable. And that's a lowercase g. Another thing to note is that the gravity from Earth decreases the further away you are. So if you are on a spaceship and you're taking off from Earth, from the ground, right? Here's your spaceship. Or we're going to call it a rocket ship, not quite a spaceship. We have not evolved to getting to spaceships quite yet, traveling around the universe, but we'll call it a rocket ship, okay? You are eventually going to hit a point in the atmosphere where gravity becomes less and less as you continue going upward, All right, so the further away you get from the Earth's center, the less you will feel gravity. Additionally, the smaller the object is, the less gravitational pull it has. So Earth's gravitational pull will cause you to experience an acceleration of negative 9.8 meters per second, that pull toward the center of the Earth. If you were on the moon, your acceleration due to gravity on the moon is a lot less. It is only negative 1.62 meters per second squared. So it is pulling you down at a much smaller force than it would pull you down on Earth. So because the moon is a smaller object, it's going to have less of a gravitational pull. You're going to feel less gravity there. All right. So now that we've kind of discussed what gravity is, let's talk about what is free fall. What happens to an object in free fall motion? All right, so free fall, another vocabulary term for you all. Free fall is when an object contains a constant acceleration, which is g. So the constant acceleration that that object contains is the acceleration due to gravity. Now, keynote with free fall, there are no other forces acting on this object besides gravity. Okay, so air resistance is gone. You are not pushing the object down. It is in pure free fall form. The only force acting on this object is gravity. It's not hitting anything. It's not bouncing around. There are no other outside forces besides gravity. All right, so our equation for free fall is the height that the object is falling is equal to 1/2 times the acceleration due to gravity, which is g, times the time it takes to fall squared. So I'm going to zoom in a little bit and make sure that we label these. Okay, so we've got our height. This is the height that the object is falling. So I can label this on this graph. Say we're looking at a baseball falling down to the ground. The height is how far the baseball travels from when it is released in free fall to when it hits the ground. Obviously, 1/2 is just 1/2. You could also calculate it in its decimal form, which is 0.5. Okay. Gravity, g is equal to the acceleration due to gravity. And that is always going to be equal to negative 9.8 meters per second squared. And then t, you should be familiar with t. That is the time it takes for the object to fall from the start to the end of that height. All right. So let's use this equation in an example here. I'm going to zoom in a little bit. All right, so here's our example. If Adriana drops a watermelon from the 3rd story of a building and it takes 3.34 seconds to hit the ground, calculate how tall the building is in meters. Okay, so we've got this scenario here. The number one step we should always do when we are solving a physics word problem is to draw a picture. All right, so I'm going to draw a picture of, that's not a great straight line. Okay, so Adriana is at the top of this building and she wants to drop a watermelon down to the bottom. Oops. So here's our watermelon. I'm going to color it black just so y'all can see that a little bit better. Okay, the watermelon is going to fall straight down from the top of the building, the 3rd story of the building. All right, so let's go ahead and label some parts of the picture that we know. Well, we always know G. We always know G. So that is always going to be negative 9.8 meters per second squared. That is, if you ever don't know what G is, look it up because you will never have to solve for G. We always know that G is negative 9.8 meters per second squared. All right. We also know the time. Okay. I got the time from this part of the problem. It takes 3.34 seconds to hit the ground. So I'm going to go ahead and label the time. It's equal to 3.34 seconds. All right. We do not know how tall the building is. All right, so we are supposed to have a certain height that watermelon is falling. We do not know what that height is. All right, so there's our scenario of what is going on in this picture here. All right, I'm going to move on to step number 2 when we are solving our physics word problems, and I'm going to make a T-chart of what I know from the problem, and that is a terrible. There you go. That's a little better. What we know and what we don't know. So I'm going to write IDK for I don't know. Okay. So again, we always know what G is equal to. We always know that G is equal to negative 9.8 meters per second squared. So I'm going to write G is equal to negative 9.8 meters per second squared. That is one thing we know. We also know that the time it takes for, the time that it takes for the watermelon to fall from the top of the building to the bottom and hit the ground is 3.34 seconds. So I can write T is equal to 3.34 seconds. All right. And looking at our equation up here, we have G, we have T. The only thing that we are missing, and this is what the problem is asking for here, calculate how tall. So we don't know what that height is. So I'm going to write height is equal to question mark. We don't know what the height is. And just gonna, okay. So that is our step number 2. We are going to move on to step number 3 in solving physics word problems. Step number 3 involves setting up our equation. So we're going to use our free fall equation highlighted up there in yellow. So I'm going to rewrite our equation. The height is equal to 1/2 GT squared. Normally, we would need to look at this and make sure that the variable we are solving for is by itself on its own side of the equal sign. Again, we are solving for H. That equation looks good. H is all by itself on its own side of the equal sign. So we are good to go and start plugging things in. So step number 4 is to start plugging things in. I'm going to rewrite H because I don't know what H is. I'm going to keep the 1/2. That will always stay the same. I can plug in my value for G because I know what G is. G is equal to negative 9.8. Okay. I can also plug in my value for T because we know what T is here. All right. So T is equal to 3.34 seconds. All right. And then remember that T gets squared. So we're squaring that value there. Okay. Now that we've got everything plugged in, we can go ahead and solve. And that is stuck to the screen for some reason. Okay. So I'm going to go ahead and solve. I'm just going to move over here a little bit and rewrite it over here so I got a little bit more room. All right, so I'm going to rewrite H is equal to, and just plug this in my calculator. So you can plug in 1/2 times negative 9.8, 1/2 times negative 9.8 times 3.34 squared. Again, make sure you are following the correct order of operations here. And you should get that the watermelon fell negative 4.66 meters. Okay, so that looks a little funky with that negative sign. But remember, when we are talking about height and position and displacement in physics, that negative sign indicates that the watermelon is falling in the negative y direction. So that is correct, but that tells us how far and where that watermelon fell. That's the height. So what we want to know, we don't care about the direction if we just want to know how tall the building is in meters. So I'm just going to get rid of that negative sign. Okay, so I'm going to say building's height is equal to positive 54.66 meters. All right, and that is my final answer. Okay, so that is one example of working out a problem and solving for an object in free fall motion. Again, remember to write your summary at the bottom of the page, and I look forward to discussing this with you all in person in class.